In this video, I'll take a look at the actual data set. Actually, here, if in Vega, you can see this question mark here. Each question mark is providing data set for the model. So let's download this. It's not really downloading. Put it in the desktop. You can save it. So, not this one. I downloaded this data. So here there's ID, test number, smallest code, and they marked each compound, which if it is training data or test data, and there's a label I mentioned, whose column name is experimental value. The better way to check the data is using Excel and drag and drop the data. Then it will split the data for you. So you can check data, source code, status is training or test set. We will go into this part later. And this is the prediction value from the model. It's a label and it's experimental value. So these compounds were tested, and these are the label assigned to each compound. It's non-toxic, it's toxic, it's developmental toxicity data. And this column is prediction value. So you can see some of compounds are mispredicted, and it happens all the time. But anyway, this column is the prediction value from the model, and these are the actual experimental value, which is the answer we want to precisely predict. So you can check many different data sets from Vega, and I want to show you the data set I'm going through. So what I want to use is this data set. Actually, they provide all the details in their paper with data set. So if you access to this paper, QSAR modeling of Daphnia magna and fish toxicities of biocides using 2D descriptors, you can see here. At the moment, I'm accessing this page through my own personal network. That's why I cannot access. But if you access through your organization or university, you can access this file, and also you can check supplementary data of this paper. If you cannot access this data, maybe you can check. You can follow up this program with the dataset from Vega. So I have already downloaded dataset, which is this one. So they have multiple tabs. In the first tab, they put title and the author information, and then there's a data. So they also put source code. Actually, author of this paper develop and maintain Vega. So they put structures, and this value, PLC50 value, is the target endpoint we want. So in their data set, they prepare this structure information and also ID of the molecule, and then these value. There's some other value in between, but these are actually same value. I think this one is also, and this is molecular weight, and they have two dataset, fish and Daphnia. So to explain what the LC50 means, LC stands for liter concentration. Oops. So what they did is they have a fish. Fish is here. And they put chemical here. And chemical in different concentration. For example, 0 as a control. And then like a 1, 10, and so forth. So they measure the number of how many fish were um, died by the effect of chemical, and then they put the dose and mortality in the graph, which should look like this if they set a good range of those, and then they find here this where 50% of fish were died by chemical, and that the concentration when the 50% mortality was observed. So these value is LC50, and they add P there, which means minus log. So it's minus log LC50. So it is a measurement to evaluate how toxic the compounds are to the fish, zebrafish here. And lower LC50 means higher toxicity because they put very small amount of chemical and quite many were died. And if LC50 is high, then it means the compounds are less toxic. So when it is converted into this P, LC50, then it means this P, LC50. So if LC50 is low, then PLC50 will be high. So high PLC50 value means high toxicity. And if LC50 is high, then PLC50 will be low. So it means lower toxicity. So these are the meaning of this value, and that's why when toxicity prediction model is developed, they are interested in predicting these value. Anyway, the main point is that we need to develop QSAR model. We need structure and this label.